Good evening, everyone. Welcome to our Computer Club virtual meeting for September. Before we introduce you to our speaker, I want to say a special thank you to Bob Delmeda. He works so hard to work with our speakers and to work on the system and to get everything done so it's a good show for you. And so if you happen to see him in the lab or something, say hello and give him a thank you, because he is the one that's responsible for putting this on. And so I'm going to introduce you to our speaker tonight. He is Joe Farro, and I'm excited about it because he's going to talk about 3D printers. I never laid eyes on one until last night when I saw the preview, and I'm excited about it. So if you've never seen one, you'll certainly enjoy this presentation. He's going to give a brief history about technology and the recent advances in both printers and filaments and discuss some of the uses of these printers. So your presenter is Joe Farro, and I'm going to turn it over to Joe. Thank you.
Thank you so much, Diane. I'm going to bring up my screen now. Okay, does that look good? Okay. I'm Joe Farro, and I've been in technology for about 20 years, and 3D printing is one of the most exciting technologies that I've had the honor of being a part of. I've actually got three 3D printers of my own. I started out with one, and it gets addictive, and you want another one. You want to print faster and then bigger. And so I've got about 5 years experience on them, and I'm just absolutely fascinated by the technology. And I'm hopefully after this talk, you'll understand why and understand a bit more about it than you may right now. This introduction slide serves a couple of uses, and what I want to do with it is I'll walk through each of these pictures because it tells a little bit of the story of what 3D printing can be. In the top left here, we have where you've got the green part. These are actually woodworking tools that have been 3D printed. This is there's a push bar, there's a 90-degree angle, there's an angle finder, there's also a center finder in there. And the reason I think that's fascinating is 3D printing is not only a hobby in itself, but it's a hobby that can accentuate other hobbies that you may not even associate it with. So if you're a woodworker, you may not think of 3D printing necessarily, but they actually marry really well together. Another one is gardening. I was looking for some things that you can 3D print for gardening, and I came up with this bird feeder below. There's decorations, there's hose adapters, there's all sorts of stuff. So again, 3D printing in itself is its own hobby, but it can create things that accentuate other hobbies. I've seen things for RC airplanes and drones and just a wild variety of stuff. In the upper right here is a Iron Man outfit that was printed, and this is from the comic book from the character Iron Man. The thing about this I thought was fascinating is this shows that 3D prints don't have to be small, tiny things. They actually can be very large, complex things that are made up of smaller pieces. This was probably somewhere between 30 and 50 pieces that were printed on a small, what I call a desktop printer that you can have at your house. And then they're assembled. And then this one looks like it's actually been primed to get ready for paint. In the lower right corner is a different 3D model of that, but it's also another 3D print. And the reason I want to show that one is that shows that 3D prints, if you look at the other three frames here, they're all kind of, monocolor or whatever. But this one shows that you can actually paint and finish a 3D print and make it look absolutely fantastic. So that's just a quick intro. Here's what we're going to talk about today. I'll go through the history of 3D printing really briefly, but mainly to show some of the different approaches that have happened and kind of tell the story of it as it gets to where we're going to talk about, which is what's called FDM printing. FDM printing stands for fused deposition modeling, and that is the style of printing that is most popular for home printers. And that will be the focus today. The hardest part of putting this talk together was getting it down to an hour because there's so many different things about 3D printing. So I'm going to miss entire sections of it. I just like you to think of this as almost like a quick buffet where we get to taste a little bit of 3D printing and give you a bigger vision of it. But this is definitely not a holistic talk. On the right here, this is a fun picture. This is actually a house being 3D printed. There's a number of companies that have been targeting this, and the goal is sustainable, low-cost housing that can be very quickly replicated. And so this is a ginormous 3D printer that is outputting concrete along its nozzle. So before we get too into it, let's talk about what is 3D printing. What if you've never seen a 3D printer? What is it actually doing? For the technology that we're going to talk about today, the FDM technology, I'm going to use something that's not technical at all that I think all of us can appreciate, I hope, and that is cake decorating. I tried to come up with something analogy that everyone might be familiar with, and I thought a cake. Well, everyone's had a cake, right? So in cake decoration, you've got what's called the piping, which is this tool on the right here. And what it does is, you can squeeze out material basically and decorate the cake. Let's say filling or whatever, icing. And so imagine if you're squeezing that out and you make a line. That's like the first dimension, right? That's a line. You've squeezed out a line. And then if you were to continue and make a square out of it, well, now you've got a two-dimensional shape. And that two-dimensional shape, as you squeeze out the ice, moved it up a little bit, and you continued with a second layer. If you were to continue that process and repeat it, what you would have is 4 walls. You've taken your square that was two-dimensional, and you made it three-dimensional. You made it three-dimensional by layering on top of each layer. This is very, very much how a 3D printer works. It's basically a robot that moves something like a piping around on what's called the bed, and instead of pushing out icing, it pushes out typically plastic through a melted or a heated nozzle. So that's a very non-technical way, and I'll show a video later that might explain it a little bit better, but that's just to get the frame of mind when you see this, because 3D printers look very different, and there's a lot of different technologies, and the FDM ones, they all pretty much go along this approach here. Okay, so going through the history, this is Dr. Hideo Kodama. He's a Japanese gentleman who invented what was called rapid prototyping. He had a patent that he was going after that was basically the concepts of 3D printing at the time. But the first thing is it was not called 3D printing yet. And the other thing is he ran out of funding, so he was never able to get his patent. But if you look through the history and try to find out like where was this concept started, this is the gentleman that started it. This gentleman here, Chuck Hull, invented a method of 3D printing where you had a vat of resin, which is like a liquid. And then imagine like a film projector projecting a black and white image onto the resin. So you say you have like a black outer border and a white square in the middle. Wherever the white light hit the resin, it would harden it. Now remember, 3D printing is really about layers. So once you harden it, then you could move that hardened piece down and have the liquid vat covered again. You could project a different shape onto it, and then you've got another layer. And you could repeat this process. And by changing the shapes, you end up with a three-dimensional shape that's got width, height, and length. That's also not necessarily, you've done it layer by layer, so it can change as it goes up. If you look at the one that he's cleaning off there, it actually is a replica of himself that he printed in this technology. The other cool thing about this is this was called stereolithography, and this is where the extension STL I'm fairly certain comes from. Now, if STL is important because if you talk about like a music file, you might think of it as an MP3. If you talk about a picture file, you might think of it as a JPEG or a JPG. STL is the file format for 3D models that are most commonly used in 3D printing today. This is 1988, and we've moved a bit further ahead in history here, but this is a laser that is used to harden powder. Now, again, the laser hardens a layer of powder. They press another layer of powder on top, and then basically another laser pass happens and hardens it on top, and so on. At the end, you end up with this print that's basically covered in powder, and when you brush it off, you've got your 3D object underneath. This is called selective laser sintering, and it was invented by these two gentlemen, Dr. Carl Deckard and Dr. Joe Beeman. 1989, 1 year later, this is where FDM comes in. This is fused deposition modeling. Now, this printer is not a historical printer. It's just a common style of one used today. But this is where the method of laying down plastic applies. And when I talked about that concept of cake decorating, that's most like to this, where you melt a layer of plastic and you lay it down as a 2D shape. You move up a little bit in what's called the Z-axis as we move up, and then you lay another layer down and you just build up the model. So layer by layer, these things work. It takes them hours to generate figures, so it's not a very quick process, but you can see the result of this rabbit. it's something that is much faster than a lot of other techniques to prototype something like that. We're going to talk about most of the rest of this talk will be focused on FDM styles, so we'll be getting deeper into this one here. Desktop 3D printing. So today, 3D printers have gone down in price. You can get them for anywhere between $200 and $4,000 based on reliability and features and size and things like that. They're $200 is an amazing price point. When I first was introduced to 3D printing about 7 years ago, they were still $2,400. So it's come down very, very fast in the last couple of years. The filament is like the ink of a 3D printer. It comes in a roll of plastic, and the filament prices are about $15 to $45 a kilogram. I'll talk a bit about how much you can print on that amount of filament in a bit here. Now, these printers that you see on the right, the top right one is what's called a Prusa, which is a very famous company that makes really high quality 3D printers. They're about $700 or $800. So if you're looking like just kind of price wise, how much are they to get into a decent one? The filament is the roll of plastic that's on top of it. And that is what's called a Cartesian printer. The one in the middle here, this is what's called a Delta printer, where it's got the three different arms. The lower right, whenever you see a printer that looks like that, that is an SLA printer. It's very similar to the stereolithography that we talked about with the one gentleman, where it projects an image on a resin. The reason that it's got that plastic color is to prevent white light or UV light from going in and curing the resin. Otherwise, you would just have a hardened block. So it needs to prevent outside light from coming in, but you might still want to see what's going on inside. So the reason I say that is if you search for 3D printers on Amazon, you'll see that ones that look like each of these, the ones with the VAT are very different technology than the other ones we'll talk about today. They're typically a bit more expensive, a bit smaller print, but a much higher quality. So this is the Cartesian and Delta I was talking about. These are two different styles of printers, but they're still both a FDM printer. The Cartesian moves in an XY plane, which is left, right is X, up and down. If you were looking down at the base would be Y, and then Z is the height. The Delta has three motors that move the arms, all three arms separately. And the benefit there is it takes a lot of the electronics off of what's called the print head. And I'll show that in the next slide here, what a print head is. But the print head is basically where the filament comes out of. By taking the electronics off of that, it makes it lighter and they're allowed to move faster. These things are two different approaches to a problem, and there's probably arguments ad nauseum about which one's better. For this, I just want to show you the two different things and so that you understand that there's two different approaches and this is what they look like, but they are both FDM. This is very common what an FDM printer will look like. So this is another model, but the Prusa I talked about earlier, you'll notice a lot of commonalities. The filament holder is on top. This is what holds what I call the ink of a 3D printer. A filament looks like a roll of plastic, basically. Imagine like a thick string, about 3 millimeters across. That's what filament looks like. It's rolled on a roll and it goes on that top holder. The display on the left is there for giving you some general information. That little knob, typically you'll see a knob like that. That allows you to do some basic tweaking of the printer, calibration, and also shows you things like the remaining time for a print. So it's just a basic display. The extruder is actually the motor that is on the left-hand side of the arm here. It's a little bit hard to see because it's actually on the back side of this printer. But the extruder is the fourth motor in a 3D printer. 3D printers have an X motor to move it back and forth, a Y motor to move it up and down, a Y motor to move it toward and away from you if you're looking at it from this perspective, a Z motor that moves it up and down. And then the fourth motor is the extruder motor, and that's the one that actually takes the filament and pushes it into the heated nozzle to melt it. The print head is the piece that's got a motor on the side of it that's going back and forth. It's got a little fan there. The fan's there to cool the filament as it gets extruded. And then what you're trying to do, basically, it's kind of an interesting chemical problem. You're trying to take a plastic and melt it enough that it doesn't get droopy. You don't want it to be like liquidy, but you want it to retain a little bit, but you want it to be sticky. You want it to stay sticky long enough that the next layer sticks to it. And so it's a bit of a heating and cooling problem. So you've got a heater on top and a fan on the bottom trying to basically balance this. The good news is over the years, they've gotten this down pretty much to a science. And these things will take care of that for you mostly. But there is a little bit of tweaking to do when you have a 3D printer on temperatures and trying to make sure that this is all the correct setting. The bottom of the printer is what's called the bed. And what's interesting about this is sometimes they actually get heated. And the reason being is to help that adhesion, help that plastic stick to the bed and not cool off too fast, you'll have a heated bed so that those will get warm as well as the head of the printer. So this is a video. I wanted to show what 3D printing looks like. And I know that I've done a lot of dancing around trying to explain it, but I think really a video might really show it. So this is a 3D printer that's going to print a model of the Eiffel Tower. And this is a 20-hour print condensed down to 30 seconds. So it's a time lapse. It's going to go very, very fast. What you see happening is it's laying down the initial layers here. And remember, it can't really move down. Once it moves up, it needs to print the next layer. It can't go back down to correct something. So it's got to print everything on that layer all at once. And then it's going to slowly move up. What's interesting here is as it prints the arches, it's actually printing it a little bit in midair, right? Like it's building on the layer below it, but it's actually stretches over in the midair to connect to the other side. The part here as it's printing, if you look at the inside, you'll see this grid get formed for the inside of this. There you go there. It's almost like a honeycomb. I'm going to talk about that a bit later. It's what's called infill, and I'll try to stop the video on there to show you it a little bit closer. But infill is a very important part of 3D printing because it has to do with a lot with the filament and the speed of a 3D print. You can see this as it's going. What's happening is the bed's actually lowering away from us as it hits the top part of the tower here. I was talking about a kilogram of filament being somewhere between $15 and $45, and I'll talk about different filaments and why they're different prices. But a kilogram of filament will print about 52 of these Eiffel Towers. So this is what it looks like close up. And you can see there's a little bit of stringiness to it. I mean, 3D prints are, they typically need to be finished if you really want to polish them off. And we'll talk about that a bit later too. But you do get the basic form. And based on technology and how good you are at it is how good your 3D prints come out.
Hey, Joe. Joe,
yes.
we have a question.
Okay.
So is the color just the filament, or is there a way to dictate the color?
The color is the filament. We'll talk a little bit about color later, but the color is the filament that went in. So this was a green roll of filament that went in.
Okay, so once you're using, like if you're using the color green, there's no way of changing it. You're stuck with that color.
You're stuck with that color as long as the entire filament roll is green. There are techniques to change colors where you can pause the printer, swap the filament out, and print a different color. They're a bit advanced in techniques, and you probably wouldn't want to do it too much. But for the most part, what that'll do is give you a different colored layer. It's typically used for things like nameplates. If you think about a nameplate, the back of it might be one color and the front would be a different. You could do something like that. Oh. If you wanted to print something like Snoopy and have it change on different parts of the character, that's not possible today with most technologies.
Okay, thank you.
Yep. This is I paused the video here so that you can see the infill, because I'm going to talk about it later, and this is really the best part to see it. It's this kind of grid that you can see along the edge here. And the reason it does this is to save filament and save time, because if it needs to have something to print the next layer on top of. If you imagine if you had like a tube of toothpaste and you're squeezing that out across like a cardboard box, it would just fall into the box. But if you can have a grid like this inside the box, then you have something to actually have it sit on top of. And toothpaste was the best. I was brushing my teeth this morning. I came up with this analogy. I was like, wow, toothpaste and filament's very similar when it's melted. That's kind of how it is. It will go across small gaps well, but big gaps that will just fall into. So, okay, let's see. Okay, the next couple of slides are going to go very technical. And I do this just so that if for the people that are very curious about what is the engineering behind this, I'll go very technical, and then we'll back up and we'll have some fun and talk about different uses for 3D printers. The STL, the slicers, and the GCode are three words you hear a lot in 3D printing. And so I'm going to break them down for you. The STL is the 3D model. Remember that stereolithography, the gentleman that we talked about at the very beginning, Chuck Hull, he invented the stereolithograph technique. So an STL file is what we call the 3D model. Now that 3D model, that data that's contained in there has no concept of your 3D printer, and all 3D printers are slightly different. Also, your settings might be slightly different. You might print at a different temperature because of your filament and so on. You might have a bigger or a smaller printer or different styles. So the STL has no concept of that. It's just the 3D data. What we need to do if we want to 3D print that is we need to have something tell basically the robot how to move to replicate that. A slicer is a piece of software that will convert that STL into basically the robot code, the commands that tell the robot how to move. The commands that tell the robot how to move are called GCode. Okay, so the STL is the model. The GCode is very specific to a 3D printer. They talk about the models getting sliced, and that's what they mean. They mean that conversion process. Now, GCode is very basic and very simple, but it's very specific to the settings you have in your slicer to make that model. If you tell the slicer, I want to go this fast, I want to go at this temperature, I want to scale the model to be half size, when you get that G-code, it's very specific to that print that you just wanted, that you set up. The other thing to know, the word that I didn't think to put it in here, it's the word profile. And every printer has a profile that tells the slicer how to print for that printer. So if I have a printer from a company called Creality called an Ender 3, there is an Ender 3 profile, and the STL gets applied to that profile, and I get out G-code for my Ender 3 printer. This is what G-code looks like, and this is basically we're almost at the bottom layer here of the technology stack, and we're talking about how the actual robot is basically instructed to move to create a 3D print. And the reason I did this is I was fascinated by how simple it is at this point. This first line here, oh, can't click on the slides. The first line there is G1 X0 Y0 F2400, which sounds like gobbledygook. Very simply, the G1 is a lettered number code that tells it what it wants to do, what the command is. And G1 just means move. The X is the X coordinate it was moved to, the Y is the Y coordinate, and then the F2400 is how fast. So this command just says move at 2400 millimeters per minute to X0, Y0. The next command down has an X in it. I'm sorry, an E in it. So this one is move again, G1 move, the X coordinate 30 millimeters over. The E is actually extrude. Remember I was telling you there were 4 motors on a 3D printer? The E is the 4th motor that pushes the filament. So this one actually tells the printer to put out filament of 10 millimeters. And how fast? At F1800, which is 1800 millimeters per minute. The next one down is a temperature command. So instead of G1, which is move, there's heat the end of the nozzle to 190 degrees Celsius. There's also T0 means the nozzle. T1 would be the bed. Remember I said the bed can get warm as well, and so on. So this is what the printer basically gets told on a very, very basic robotic level to go do. Okay, so I was talking about that grid, and I called it Infill. What is Infill, and why do we need it? Well, we need it because of physics and gravity. If it wasn't for gravity, 3D printers wouldn't need Infill. But the problem is, if you're printing across an opening, if you're printing something that is expected to be solid, you have to have something for the bead of filament to go down on. If you're familiar with caulking or, again, toothpaste, imagine, you can't do that in midair. It's got to go across some kind of support structure. But what's cool about Infill is it's adjustable, and there's actually different shapes of it. Some of them are purely aesthetic. Some of them are very functional. Because you're not filling it solid, anything that you take out and create air gaps, you're going to make a print that is a little bit less structural. So it depends on what you're 3D printing. If you're 3D printing, say, a pegboard holder, and you want to, hang up some wood or something on a pegboard, then you're going to probably want something more structural. If you're printing, your cat, like a 3D model of your cat, it's more something that's not going to need any structure, so you can have more of a gap in there. Infill is referred to as typically an infill percentage, and 20% is a very common value. Looking at these are all different designs of infill, and each one has a different structural or aesthetic look to it. I would say 20% is probably the honeycomb on the bottom left, like 3 over there. That's about 20%. Another benefit of infill being only 20% is you use a lot less filament and you get a lot more speed. So it doesn't have to sit there and fill everything in. So 3D printing, you know, that Eiffel Tower I said took 20 hours. If it wasn't for infill patterns, it would probably take 45 or 50 hours. So it speeds it up considerably. The bottom left corner is a square that has 0 infill in it. So that's just an example of what would happen if you didn't have infill. You'd have an opening. Okay, so that's on the inside of a model, but what about the outside of the model? Say I'm printing this dog here, and remember, I start at the bottom and the printer moves up. And it gets up to about the dog's chin or nose area, and now the printer's trying to print that nose. Well, remember, we cannot go out in the middle of thin air because of physics. The filament would fall. So we need a support structure that will hold the filament up, and that's what supports are. That slicer software I was talking about will generate these for you automatically, so you don't have to worry about it. But when you get your dog out of your 3D printer, if you were to print this dog, it's going to look like the picture on my left, on the left, where it's got that support holding the chin up. Now, what's cool is it generates that algorithmically, and it does all the math to figure out how much that is, or how to put that there and where it needs to be. And then it also makes it super easy to take off. So that breaks off very simply. You grab it and pull, and it's designed to break away very simply, but it's just enough material to hold that nose up so that the print looks correct. So that's what a support is. And support and infill, when you get into 3D printing, are very important concepts to understand, like, do I need supports for this print or not? The going rule is a 45-degree angle. A 3D printer can print up at a 45-degree angle. So if you imagine like the pyramid flipped upside down, as long as the slant isn't more than 45 degrees, the printer can actually print on top of the layer below it and expand out. If it's more than 45 degrees, then you have to have a support. Filaments are awesome. Filaments are the ink of a 3D printer. This is what you're going to print in, and this is going to go to the question of colors. What's cool about filaments is the technology behind filaments has really outpaced the technology of 3D printers. So even my printer that I bought 4 or 5 years ago, I can use filaments today that make it do things that I would never have expected. The most common filaments are in this chart on the left here. PLA, I would say, is probably the most popular 3D printing filament. It's very inexpensive. It doesn't create toxic fumes, which is important. It's biodegradable in a way that it would, they say it would decompose in about 90 to 100 years versus the thousands of ABS. And it's very, very easy to print. It prints at a very low temperature. The downside, though, is if you were to print this, and especially being in Florida, if you have it on your car dash, the heat's probably going to melt it. So it's not very heat resistant. ABS was the king of 3D printing at the start. It was the filament that I saw used most, but it does have toxic fumes. So you want to print it in a well-ventilated area. And ABS plastic, you've used it before. I'm almost guaranteeing something you have is ABS in your house. It's used for injection molding of quite a few things. Everything from Legos, a lot of kids' toys, computer shells, all of that is made in ABS plastic. On 3D printers, it was what was really popular at the time, but it is a bit harder to print because it warps. It's very temperature sensitive and so on. PETG is a new, I was talking about like filaments advancing in technology. PETG is the new hot one right now because it has the benefits of ABS where it has that heat, the heat resistance of ABS, but it's easy to print like PLA. It's got the biodegradability like PLA. So it's a very nice filament to print with. It is a bit harder to print with. It prints a little gooey. So it takes a little bit more practice, and it's harder to sand and smooth down. Nylon's a very hard filament. I'll show you an example of that in the next slide. On the right here, I've got a couple of filaments that I call exotics, and they're just really cool though. TPU is a flexible filament. If you wanted to print like a jewelry or a wristband or a necklace or something that was bendy, rubbery, TPU is what you would use. Wood infused filament is amazing. They take like almost like a sawdust and they put it into PLA. So it acts like PLA when you print it. But when you get done, this elephant in the upper right-hand corner, that was not carved. That was actually 3D printed in wood filament. Not only can you sand it smooth, but you can actually stain it like wood as well, and it will react to stain as you would expect. So wood filament's cool. Metal infused, similar to wood, but with metals in it. A bit harder to print, but I'll show you some examples of that in the next slide. Glow in the dark, super fun. You print things and then turn the lights off and they glow. That's great. This is all Halloween decorations you see at the top there. Those were done in glow in the dark. And then rainbow filament, which I'll show you on the next slide, and which breaks everything I said about colors. Here's some examples of 3D prints. The upper right-hand corner and the middle are a brass infused filament. What's cool about these is these are metal infused, but you can actually polish them up and they'll react as it, they'll react to brass polish and they'll actually shine up a bit more. The other thing about the brass ones is they'll patina. So if you wet them and let them sit outside, you can actually patina them, which is really cool. The upper left-hand corner, that's actually a PLA, but that's a fancy PLA called silk PLA that has been incredibly popular lately. The silk filaments have this really cool luster and sheen to them. That's not painted or primed or anything. It's probably a lightly sanded, but that's almost a raw 3D print that was just really well done. I can't guarantee there were supports there looking at it that were removed, but other than that, that is what that filament looks like. The lower left is the rainbow filament. And quick story about 3D printing. You get a 3D printer, you get your favorite color. I got a blue filament when I started out and I started printing things. And that filament seemed to last forever. I think it lasted for a month. And I was printing knickknacks and putting them all over my house. Here's the problem. Everything in my house was blue. My headphone holders were blue. My USB holders were blue. Everything was blue. And I was so sick of blue by the end of it. Rainbow filament, if you print something really large, what it is as they wind the filament, they change the color of it. So it's actually all of those colors. You can see it on the roll that it's on. If you print something large, you get a multicolored print. If you print something small, everything comes out whatever color is on the filament roll at the time. And it's just fun because it's kind of like a random color. It's something pretty. It comes out rainbowy and who knows what you get. So that's rainbow filament. Lower right, that's nylon. So these are prosthetics that were done. And so something where you're going to have a lot of usage and you want to have it really protected. That's where you would use something like a nylon filament. So I've shown all of the perfect world of 3D printing. Is it perfect when you get a 3D printer? It is a hobby and it's not what I would call, it's not like a 2D printer. It's not like your printer where you throw things in and 99% of the time it works. 3D printers, I would say for mine, I'm about 80% after 5 years. There's very often problems and there's things that you have to understand and learn about them. One of the top problems with 3D printers is adhesion. This whole concept of heating a plastic and getting it to stick to that bed, that flat area, it depends on a lot going right. And one of those is like your Z offset, how high up your Z is. If that goes wrong during the 3D print, and again, let's go back to that Eiffel Tower, that was 20 hours. If you're 18 hours in and the adhesion breaks and that thing moves off the bed plate, the rest of the print will be ruined and you can lose the entire print. So adhesion can be a very big problem, a very frustrating one, but it is something you get better at over time. E-steps, I talked about printers use that fourth motor that controls the nozzle and how much filament goes in. That needs to be calibrated. And it's very simple to do, but it is something that you have to know about and go do. A lot of 3D printers don't come with the best instruction manuals of all of these things and how to use them. And so it takes a bit of YouTube and communities, and I use Facebook groups a lot to really get good at this. And basically, you want to get into a community that you can talk and ask questions. E-steps, if they're not calibrated, if you tell the printer, give me 100 millimeters of filament, and it's not calibrated, it might give you 120, and that 20 millimeters has to go somewhere. It's typically a big glob on your print every so often. So if it doesn't give you that, you end up with dips. So E-steps is important. Nozzle clogs, some of those filaments like the wood infused, you can imagine if you take wood, you melt it into plastic and you're printing this beautiful wood elephant. Some of that wood gets not clogged in the nozzle. The nozzles are 0.4 of a millimeter by default. A lot of them you can get smaller and bigger, so on, but 0.4 of a millimeter, it doesn't take much to clog it. So nozzle clogs are common. You just have to learn how to clear them out. And then the beds are typically not perfectly level. And when I say level, I don't mean level like we would think in woodworking with the ground, but level with the nozzle. As the nozzle moves across, the bed might be warped in some way. And so there's a bit of work to do to try to make sure that your calibrations are correct to adjust for that, or to basically put tinfoil under your bed to try to fix the holes in it. So these are some of the challenges. Okay, fun stuff. Fun 3D prints. We're going to talk about, I'm just going to check how I'm doing on time. Okay. So I heard that in Florida, there were a lot of golf carts, and I didn't know if that was for golfing or not. So I could try to play to my audience and come up with some golfing ones. The one on the left is a rake for getting balls out of the sand traps, and it attaches to a club. It's a 3D print. I would not suggest any of you would need this, of course, but if you go with your competitors or your friends, you would have something that you could 3D print and offer them when they got their balls stuck in the bunkers. The one on the right, if the golf carts are just for luxury, you've got a fan holder. Now the fans are not 3D printed, but the holder underneath it is custom designed for that golf cart. And what's cool is if you search for like golf cart accessories on a website like Thingiverse, you'll get tons of models back that are made for different golf carts. Then you can download those models digitally, just like you download a file. And then when you print them, you get something physical out at the end. And that's, to me, one of the wonders of 3D printing. It's like having somebody email you a physical thing. This is one of the early 3D prints I did. This is not my model, but it is one of the most fascinating things I've ever printed. It's a CNC machine. So I basically used a 3D printer to print another robot. All of the pieces that you see are red and light gray on this are parts that were 3D printed. And this is a gentleman out of California. He basically offers these plans up for free. You can download his 3D models, and he makes money off of support and the electronics kits that he sells for this. His electronics kit is about $400. And with that, I was able to create a CNC machine and actually do some carving. CNC machines of the size that I built were typically run about $2,500. So this allowed me to get something built that I did myself that was a much lower price. And the other cool thing about this is because it's 3D printing, as people came up with new ideas, such as converting this to a big 3D printer or using it as a plotter, they were able to print or offer add-ons. And then I would be able to download their add-ons, plug it onto my CNC machine, and then have it do more things. If you're not familiar with a CNC machine, it's a robot that can move a spindle, which is a spinning bit of metal. Think like almost like a drill bit, a little bit different, or if you know of routers, but very precisely. The picture on the right is a CNC of a 3D Pegasus. So it just kind of shows the accuracy that can be gained with a CNC machine. This is an instance of a 3D printer printing another robot, basically. These are called lithophanes. And, I was trying to think of what can you really do with a 3D printer that would be hard without a 3D printer? Lithophanes, those slicer software I talked about, you can take a photo, put it in the slicer, and generate these. And lithophanes are backlit pictures that show up when they're lit. The lamp in the upper left kind of gives you a hint of that. You can see when it's not lit, it doesn't really look like much, but when it's lit, you can see the sailboat. They show up really well. And the reason that they show up so well is the plastic behind it is layered in 3 dimensions to create a resistance to the light to give it the shading. You see this dog one in the middle here, a beautiful dog, and also very, very well done lithophane. The color or the contrast on that's really well done. And on the right is a lamp that was done that I thought was really cool. It's a custom lamp. And if you were to take a photo and want to generate one of these, I feel like I don't know how you would do it other than this. So 3D printing allows it to be very easy. And that might even be sitting around a tea light for all I know. So it's not even any electronics to put that together. Okay, what else? Veroni lamps. So you can print a million things. I picked some different things that I thought were cool. The lamp on the left I actually built for my wife. Veroni is a mathematical formula that is used for a number of things, but one of the cool things that I've seen it's used for is for placement of like hospitals or any kind of support structure for a given population. So if you have like, 2 cities that are close to each other, one has twice the population, and you want to place a hospital, then where would be the most efficient place? That's what the Veroni algorithm does. The other thing it does, though, is it generates these cellular, almost biological patterns to it. So the lamp on the left I built, and I put a colored light into it, and it changes colors, and my wife really loves it. But again, I couldn't carve that in wood. I don't know how else I would build that, but it came out beautiful. On the right, the lamp is very small. It's on the table. I don't know if you can see it, but the thing about this lamp is this is mine's a Veroni lamp that's diffused. This is what happens if you don't diffuse it. That lamp generates this huge dramatic lighting pattern all over the wall. So just a cool like arts and crafty thing that you can do with 3D printing. We're on November 9th. So I'll talk about this one. I'll talk about another one right after it. This is Limitless Solutions. And this gentleman, Alex, he was born with partially formed right arm. Now kids, I believe it was 20 million amputees or partial limb humans are on the planet each day that need something. And the thing about kids is they grow, so it's a big challenge to come up with a prosthetic. They're expensive. They're typically somewhere between $20,000 to $100,000 based on the use of the arm. And kids they can be a bit rough when they play. And so putting this super expensive thing onto them is really hard. And then they normally don't look cool. And so that's kind of a shame, right? You've got a kid that's probably dealing with social issues from looking different. And then if you give them a robot arm, that's not cool. So Limitless Solutions went out and said, okay, let's make it cool and expensive and in a way that can adapt to them. And that's what they were able to do, because 3D printing allows them to prototype super quick and generate these arms and then generate them for a fraction of the cost. 3 days ago, a company just announced 3D printed arms like this, similar, that were actually controllable via the brain. And they're selling them for $8,000. Now, keep in mind, the hook version that didn't have anything cool, wasn't really manipulable, was going for $10,000. So to have something that was custom and kind of cool looking and so on for $8,000 is a huge step, especially when the equivalent was, upwards of $50,000 to $100,000. So this is one company, and I've seen two others in the last couple of days that have come out with this. So 3D printing in a different format. His arm looks like Iron Man, and what's cool about this story is it was actually handed to him by Robert Downey Jr., the actor who played Iron Man in the Marvel movies. There's some videos on YouTube of it, and the kid was a lot cooler than I would have been if Robert Downey Jr. gave me an Iron Man arm. So 2020, so you guys heard about this thing called COVID. This was a thing that happened for me personally. Our hospitals here up in Washington, we got hit by COVID. And as a lot of you know, the hospitals couldn't keep up with personal protective gear, PPE. And one of the pieces they couldn't keep up with was face masks. Now, we talk about masks as being the big thing, but a face shield is good, because if you have to intubate a patient, a healthcare worker intubates a patient, the eyes and their other orifices need to be protected. The other thing is this allows the mask to last longer because it gets hit less. But the problem is there were none, and trying to get that whole thing moving was taking a while. So a group of us in Washington formed together. It ended up being a group of over 300 of us, and we donated to hospitals 10,000 face shields before Amazon stepped in. The plastic parts here, the headband and the bottom, are 3D printed. The clear plastic was actually just like a binder plastic. This is one of the models. There were many up there. And what was cool is some of the models we were printing in the US were actually coming from other countries. So they were doing the designs. We would print them here. The hospitals would give us feedback. We could tweak the designs and the next day give them a new model. So it was a very rapid delivery system. And we had, I want to say, about 60 printers going between the 300 of us. And basically we became a little mini factory of generating exactly what was needed at the time. So that's a use of 3D printing in a bit of a different sense, but it was very helpful. And this happened all over the world. There were entire communities that were joining together remotely to help provide PPE to healthcare workers. Now, I don't want to leave you with a COVID story, so I wanted to do a slide that was a bit more fun. These are some other 3D prints. The bottom left is a company that's created a shoe using 3D printing. 3D printing has hit the fashion industry. It's hit every industry, really. But in fashion, there are entire dresses being made with 3D printing, and of course, shoes. And what's cool about this is there's, the colors, the designs, there's quite a bit that can go into it. The upper right is a print I did recently for a self-watering planter. The white portion is a basin of water, and then the green portion, the plant sits in, and it has holes in the bottom, and it sucks the water up through vascular means. Basically, it sucks the water up. And then the white straw on the side, you can look in there and see if it needs to be refilled. But I can water my plant once every 2 weeks instead of daily using something like this. Fun little 3D print. The top left is cat armor. There's always something goofy in a hobby, and that makes the rounds in the internet. And cat armor, somebody designed this for their cat, and a lot of people took to it. His cat wears it very proudly. There's a lot of pictures of cats on the internet where people have printed it, and they're not so happy. So it's your cat may vary, but cat armor. Post-processing. So we talked about the color of 3D printing. Well, the color of 3D printing can change and such that you can finish a 3D print and paint it and smooth it. You do this very similar to how you would do anything with wood. You can glue them together using super glue or CVA glue. You can use spray primer to kind of fill in there's kind of a gaps on it, or you can sand it. And then there's also epoxy fillers that you can use. You pour an epoxy filler on, it'll kind of fill in the gaps and harden. You lose a little bit of definition, of course, if you do it that way versus sanding it down. And then on the right, you can see the paint job there. So while the 3D prints, a lot of the ones I've shown don't look super fancy. If you want a model or something really nice, you can paint it and make it look really nice. Where do you get prints from? Where do you get the models from, really, I should say? There's websites out there that are search engines that have thousands of models. Thingiverse has all free models, and I've found almost anything I've ever looked for on Thingiverse, some really odd things. I get a lot of cool ideas for 3D prints from Thingiverse, toys for my daughter and so on. There's miniatures of things. If you want to collect miniature buildings, they have miniature buildings. If you are looking for a code hook, they have a code hook. If something broke, they probably have a piece that will help you fix it. If you're in IKEA furniture, they have a million add-ons for IKEA furniture. It's almost like its own community. So Thingiverse is out there. There's other sites like My Mini Factory that sells miniatures and fan models. When I say fan models, I mean like Iron Man or Snoopy or whatever you're into if you want to print like miniatures of those. And then there's other ones. Some of them do charge for the models to come down, but the amount of free stuff out there is absolutely astounding. The other thing that 3D printing has done is driven the industry to create tools to make it easier to create 3D models. Tinkercad and Fusion 360 are free. Fusion 360 has a free license for individual hobbyists. Tinkercad's a free web design. I didn't know how to create any 3D models, and I used Tinkercad for, I'd say, 15 minutes and felt like I knew the basics. And 2 hours later, I had a toothbrush holder. So, and personalized too, right? Because it's 3D printing, I could make whatever I wanted. So you can create your own models. And then 3D scanners are the new thing that are trying to come down in price. They're still $2,500, $500 somewhere in there. But they basically, you can walk around a model and create a 3D model from it and then print that. There's also apps on the phone now where you can take a bunch of photos. So you can go to like a landmark, take a bunch of photos as you walk around the landmark, and then create a 3D model of that. It's a bit more complicated, but it's different approaches to getting basically the content you need to 3D print. Where's the future of 3D printing going? These are my guesses, but based on what I've seen of technology and where it's headed, cheaper, faster, bigger. So typically it's cheaper, faster, smaller. But that 20-hour print for the Eiffel Tower, we need to get that down. A lot of 3D prints take me between 1 to 4 hours to print. And so it's got to get faster, really, to be rapid, more rapid than it is. Cheaper, you know, they got down to $200, but that is still a printer that has some issues. So maybe those $4,000 printers that are more reliable will come down to that price range. Reliability, I talked about being at about 80% after a couple of years. The reliability needs to get better. Bioprinting is getting better and better. Bioprinting is the printing of 3D organs. They've printed a couple of them, but I think that that's a huge, its own technology market that will open up and allow us to reproduce organs. What's cool about that is those organs are typically using the same cells from the body that are donated to create them. So there's no rejection issues with those organs that get 3D printed. NASA. So this is a picture of the International Space Station. I have a 3D printer up there. I thought, how cool is that? You know, if you watch movies, Apollo 13 or whatever, and you think about the history of that problem where they needed something in space, and you don't have anything to build with, an engineer on the ground could actually design something and send it into space as a digital model, and then they can recreate it and have it in their hands up there, a part that they need or a piece or whatever. And I think that's really fascinating. When we think about, you know, if somebody's on Mars and they need something, a 3D printer could be the factory that can generate whatever they need or the tools instead of trying to ship them with an entire Home Depot in the back seat. So some ideas of where it could go in the future. I have a a channel on YouTube called Geek Toolkit, and I've got a couple of other videos that are follow-ups. Each of these videos is about, I think, 10 to 20 minutes long, but it talks about things I wish I knew before 3D printing, which talks a bit in depth. Printing tips for beginners. This talks more about like how to actually calibrate a 3D printer. There's tons of YouTube videos on 3D printing. And then the Veroni lamp that I made for my wife, I describe how to build that and hook up the electronics for it. So if you want more, that might be some resources. And I can take questions now if we have time. How'd I do? 4:50.
No, we're looking at questions. No,
All right.
Joe, it looks like we're all set.
Thank you so much, everyone.
Yes. Thank you, everyone. Okay, and hey, if you liked what you saw, please click on the subscribe button below and click on the little bell. You get notifications of upcoming events. And Diane, if you'd like to close us out.
Thank you very much for joining us this evening. We hope you enjoyed it very much. And remember that our lab is open now. So if you have an issue or a problem, and you want to come in, or if you need to use a piece of equipment, please feel free to come in. We're still open 6 days a week from 12:30 to 4:30. Good night, everyone.
Good night, everyone.